Let's talk about voltage. Imagine electricity is like water flowing through a pipe. Voltage is like the water pressure that pushes the water through the pipe. The higher the voltage, the stronger the push, and the faster the electricity flows. Think of battery, it's like a water tower. The higher the water level in the tower, the more pressure it has to push the water out. Similarly, a battery with a higher voltage has more power to push electricity through a circuit. The standard unit of measuring voltage is volt and is represented by letter V. Now let's talk about resistance. Measures how easy or difficult it is for electrons to move through a material under the influence of voltage. We use a device called resistor to produce resistance. If you imagine electricity as water flowing through a pipe, resistors are like the little rocks in the pipe that slow down the water flow. They control the amount of electricity that can pass through a circuit, just like a wall controls the flow of water. The unit of measuring resistance is ohm. Now let's talk about current. Imagine electricity as river flowing through a pipe. The current is like the speed of the water flowing through the pipe. The unit of measuring current is ampere, represented by letter A. Now let's talk about Ohm's law that provides a relationship between voltage, current and resistance. This equation helps you to find the missing parameter if you know the values of the other two. Now let's see the real life Ohm's law usage. Let's do an experiment to lit an LED. Now let's talk about this LED. LED is a device that emits light when current is passed through it. Brightness of the LED is proportional to the current passed through it. Now let's try to calculate the resistance needed. So the LED operates at 20 milliamps and we have a power supply of 5 volts that gives us 250 ohms minimum that is required to safeguard the LED from the current passed. This is the circuit diagram. We have a 5 volt source and connected to a 330 ohms resistor and an LED. Now let's see case 1. As you can see, the brightness is more when 5 volts is applied versus 3.3 volts. Before we move to case 2, let's understand potentiometer. The picture in the image is a 10K potentiometer or a variable resistance. It is used to vary the resistance in a circuit. You can find 10K at the end terminals and the middle terminal is a variable. As you can see, keeping the voltage same and increasing the resistance will decrease the current and vice versa. I have created a separate playlist for all the basics. Please do watch it in the channel. Thank you.